Okay, so we ended here, got through the seesaw. Just remember, like I said, not a teeter-totter. It is a seesaw is the correct name. So you can once again see quite a few to memorize, and I haven't been going over all the bond angles, but like on a lot of them, it's just how far apart they can get. So 120 degrees is as far apart as you can get um, with a flat structure with that central atom. Then you can go to 107 with the pyramid. T shape is a 90. Tetrahedral is 109.5. So there's like a bunch of bond angles. You don't see one here on the seesaw because there's multiple. If there are multiple, basically, usually any of them will work. That one just I guess you could do 180. It has a lot of stuff going on. So um, here we go. We are, as you can see, the the seesaw with 5 electron domains. So let's remember, electron domain is basically the x's and the e's added up. Okay, so with 5 electron domains, that's an expanded octet. It means it has more than 8 attached to that central atom. So those electron domains, if it was a seesaw shape and they ask why, you could say it has 5 electron domains that repel each other. Boom. If it's tetrahedral, you could say it has 4 electron domains that repel each other. If it was T-shaped, and they say why, you could say because it has 5 electron domains that repel each other. Do not say it's T-shaped because it's an AX3E2, or it's tetrahedral because it's an AX4E0. That is just a way to know these and to understand how to memorize them. That's not a reason why it's the pyramid shape. So don't say AX3E1, say it's a pyramid shape. It's pyramidal because it's got 4 electron domains, and those electron domains repel each other. That's really important to kind of understand. It's all about the electrons pushing each other. It's not about the A's and the X's and E's. That's just a way for you to memorize it. Okay, so here we go. Some more expanded octets. And so we've got this first one here. So we've got, these are E's, and these are X's. And of course the A is, there in the middle. So we got a lot going on here, but look, it's actually a flat shape. So it's a flat shape. And so normally that can kind of help you determine what the heck is going on. And so this one is a square because it is a square, and it is planar. So it's a square planar. 90 degrees on the bond angle. Again, the square planar. If you can kind of visualize that flat piece, that will definitely help. So we start getting into some kind of squirrely ones here. No E's on this one. It just has a bunch of X's, so like a whole bunch of stuff attached to the middle. And so if you look at this one, it has basically there's like on the top here, there is a triangle. I'm going to draw it a little bit better. So if you look, there's a triangle right there on top, and there's also a triangle on the bottom. Kind of hard to see that one, but there's a triangle on the bottom. So there's a triangle on the top and a triangle on the bottom. So you actually have triangles on both top and bottom. So we're going to call this a trigonal for triangle. And then there's 2 pyramids. So we do bipyramidal. So trigonal bipyramidal, right? So bi for 2. So 2 pyramids, one going up, one going down. So the pyramid going up and the pyramid going down. All right. Then these are the couple more. We got an E on this one. hanging out down the bottom. So there's your X's. And of course the A is in the middle. And so on this one, it's a square pyramid, right? So like it's got a square down here on the bottom, but then all of those sides go together to make that pyramid shape. So this is a square pyramidal. And then the last one here at the bottom on this page, all X's, and you would think, okay, it's square, right? And it's a pyramid. So you would kind of think, well, it would kind of make sense that there would be like square bipyramidal, one up, one down. That would be super smart, super easy, but it's not. It's not square bipyramidal. It's octahedral because it has 8 sides. Try and write that a little bit better. This is octahedral. So it has 8 sides. So it's basically like a diamond in some regards, like a traditional easy looking diamond shape. And it has like, so if you think about it, like this would be a surface right here. So there's 1, and then there'd be a 1 on the opposite side, right? 2, and then you have 1 here, 3, and then 1 behind that one, 4. So there'd be 4 on the top and 4 on the bottom. And so that's kind of where you get that idea of the octahedral, is because it has these 4 sides on top, 4 sides on bottom. But be nice if it was an easier thing to remember, but there we go. So, all right, let's see what we got here. Let's go down and take a peek at some of our shapes. There we go. There's your square planar, nice and flat. You can see the E's in the middle balance out. They push all the atoms away. Remember, it's all about repelling. And so like on this one, I could say, oh, it has 6 electron domains that repel each other. That's why it's a square planar. And here we go. There's our square. There's our, see, there's your, kind of pull on them, but it does bounce back to your square pyramidal. So once again, I could say for a Y, I could say, oh, it's got my why is it square pyramidal? Once again, 6 electron domains. That's why it's square pyramidal. And there we go. There's the trigonal bipyramidal. So I can say, oh, it has 5 electron domains. That's why it's trigonal bipyramidal. So you can kind of move these around, but they always kind of bounce back because see, look, they're repelling each other, right? So even if you pull them next to each other, they push back, and that's that idea of that repulsion. You can't put them next to each other. And we'll end here with our octahedral. Once again, when I put them next to each other, they repel. So that whole idea of repulsion, I can put this element wherever I want, but these electron domains, they're going to repel and they're going to go back to where they were. So there's your octahedral. Once again, I'd say 6 electron domains that repel each other. That's why it is octahedral. So it doesn't really matter how I move these electron domains. They're gonna push. They're gonna repel each other. So that's what I really want you to take away, is the idea of the repulsion. Kind of fun thing to move those models around. All right. Now, that's not all the shapes, but that's all the shapes that IB is going to test you on. These are not on the test, so you might want to, these are not tested. I just wanted to give you all of the shapes, but these are not tested. So you want to make a note to don't memorize these. Don't worry about these. That's why I gave you the pictures there. You've got an AX6E1, a pentagonal pyramidal, and then an AX7E0, a pentagonal bipyramidal. once again, I will not test you over these, so you should not memorize those. Okay, so these are not tested. All right, so and then I put this on here because when you're drawing things in on a piece of paper, you're drawing them in, you're trying to take a three-dimensional object and draw it. Well, like this is awesome, right? Like I've got this computer model and I can definitely see that this square planar is flat, and then I can go over here and I can look at this seesaw and see that it's not flat. That's easy to see the three dimensions. Well, if you have to draw that on a piece of paper, like that's really hard to show the three dimensions. And so, like, what happens here, and this is a little hard to see, but if something has legs, you're going to draw the legs as either a wedge or a dashed line. So like if I'm doing a tetrahedral, I would go put my A in the middle. So I put my A in the middle, and then here's an X, and here's an X, and then this would be like a leg with the dashes in it, and there's another leg. So what you do is if you have these dashes like that or this wedge, those are things that are not in the plane. They're not flat. So they're things that are either coming towards you or going away from you. Do you need to know that for this test? No. I'm not going to make you draw them in three dimensions. This is just something to if you see this, they're trying to show you something like this in a two-dimensional format, which is a piece of paper and a pencil. So that's kind of the the modeling is like way the heck better. Anyway, so there you go. Do you have to know these shapes? Yes. Do you have to memorize them? Yes. They are going to be on the test. Do you have to memorize these last couple? No, they're not going to be on the test. But you do want to be very familiar with these. These are easy points if you've gone through and you've memorized and you know them. If you decide not to memorize them, you're going to wing it. There's a lot of them. So you're going to do a lot of guessing. So just kind of be aware of that.